like a application like Blinkit, Swiggy, or any kind of Zomato kind of application. Like I can tell the preparation time of a naan or a bread that is being made. It is not easy to judge the preparation time of that, but I can classify these. If you take it in a banking industry, whether it's a kind of a fraud detection that happens in a typical bank industry. Hi all, welcome to this session of predictive analytics using machine learning. Myself Kuruvilla Abraham. I work as a senior scientist in TCS RSI department. Yeah, let's go ahead and let's see the agenda for today. So yeah, today we'll be focusing about what is predictive analytics. What are some typical business applications of the predictive analytics, and what are the steps taken to build a predictive analytics application? And we'll see a small demo in Python using all the things. Okay, so yeah, let's go ahead. Yeah, let's take ahead. What is actually predictive analytics? So predictive analytics is nothing but gathering insights from a historical or previous records and making better use of them by uh, understanding the insights behind them, and then typically using some statistical methods or data mining approaches, and then uh, on the basis of the feedback of all the methods, so we will be coming to a conclusion that what is right or wrong, or whether uh, so this is the typical Wikipedia based knowledge that I'm talking about. So in a typical predictive analytics approach, we see that we identify our variables, how are they, and what kind of variables are we using, and how important are they to a business problem. Identify the relation between our variables, whether they are strongly related or not, and using that, we try to analyze the data and come to a conclusion that whether it is right or wrong. So let me take you to a typical predictive analytics. This is a formal definition of a predictive analytics. Let me take you to a typical example of a predictive analytics, application. So let's say we talk about a typical, kind of a like a application like Blinkit, Swiggy, or any kind of Zomato kind of application. In technical terms, it is also known as hyperlocal delivery. So this chart that you're seeing is a food preparation time that we are seeing. So let's say Mr. Sharma orders a gulab jamun to a restaurant, so that a restaurant gets triggered, and so it takes some time, and then after waiting for some time, the delivery person arrives, he gets the order, and then it delivers to the last mile location, which is also called the customer location. So in this, what is happening? If you see in a typical application or in a typical kind of app that we are seeing, if I send my delivery person to the location very soon, or where there are many, so it might be that he loses time. He might have to wait at the location for so much time, uh, where he could do other orders as well, and then it delivers to the customer location. Or instead, if I send my customer to the location in like kind of uh, if I send my delivery person to the location very late also, so the customer might get frustrated, and I might lose a business option also. So these are the typical things that might happen in a food preparation time. So all these are minor activities that are going on. The food preparation time that is going on, the person who is waiting at the restaurant to collect the order, and then after collecting order, he delivers it to a last mile location, which is also called the customer location. So in this, what we see delivery time, if we have the idea, if we have the knowledge of the food preparation time that we take, we can save the delivery person's time. Even we can deliver the food on time to the customer. So what do you think typically what happens in a food preparation time? So all these people are juggling, okay, right, and kind of making the food. But instead of that, to understand, we can understand the data here. So what is the data here? The data typically here is cuisine families. So cuisine family, what I may not say, to like I can tell the preparation time of a naan or a bread that is being made. It is not easy to judge the preparation time of that, but I can classify these. I can make that the bread, the type of breads makes x amount of time, or the type of like kind of vegetable preparation, or the Chinese or the starter preparation make an x amount of time. I can gather information related to that. Also, then I can try to predict the food preparation time that would take, so that I would not make my delivery person wait. So that when the food is prepared, I send a trigger to the delivery person who is standing near to the restaurant that the food is prepared, pick up the order and deliver it to the and deliver it to the customer. So all these are minor orchestration that are taking place. It's kind of a loop system that if you would see in the previous slide. So it's kind of a loop. It has a two legs, right? So all these could be fine tuned. So how it can be fine tuned is like when the food basically typically reaches to the customer, we can calculate the time that it would take. Let's say my model predicted 25 minutes it would take to typically prepare that bread or a gulab jamun that Mr. Sharma is asking. So but instead of that, my actual food took like 27 minutes. Okay, so there is a margin of 2 minutes. So those margin of 2 minutes would make my model being learned. My model is learning that. So instead of 25 minutes, it typically takes 27 minutes to make that bread, or to make that food item, to prepare that food item. And then typically it uh, you know uh, gets the feedback, and on the next time it predicts it with less marginal errors. So this is how it's a typical loop system, and this is how predictive analytics can be used in vast majority applications. So in the next few slides I would show you typically how like it would take you can use predictive analytics in n number of business applications, and you can even imagine like how they are going to be used. Okay, so these the balls that you are seeing, right, like the balloons that you are seeing in different colors, these are all different type of activities that my business applications uh, could be used. So whether it is in campaign environment, so in campaign environment, so let's say typically yeah uh, you are hosting for elections, so we can understand the major factors that led to the election win, or the person win, and what other techniques are there which we could arrive to a decision whether the person who is selected is right or not. So all these decisions could be streamlined using a typical campaign management tool. So uh, so whether you can understand from it is like what we can get a takeaway from this, like, and we could avoid the major hidden things that are going on behind the election polls and all. So we can build an application which could do this. So instead of like the other things, like you can typically take it in healthcare system, whether it is to predict the kidney failure, whether it is to predict the breast cancer that would take place. All these things could be done using by studying the historical reason, by studying the images, by seeing typically what is the history and all, and come to a conclusion that the the kind of it's a cancer, or so the kidney failure or something like that. So typically you can imagine what all we can use it. So there are many areas where predictive analytics can be used in, whether you can imagine tabular data, whether you can imagine CSV, anything, even images that you can take. Even using the images, you can make certain predictions. You can build a normal classification methods, all those things. So the next thing is like, if you take it in a banking industry, whether it's a kind of a fraud detection that happens in a typical bank industry, uh, whether you have to calculate the risk that is associated with the bank. There are some underwriting that are happening. So how much risk is there, uh, you know, in those application? So all these things could, whatever you can imagine can be, calculated using the normal predictive analytics application. Okay. So yeah, let's talk about some typical steps that you would undergo in building a normal predictive analytics application, or a machine learning, or you can say deep learning, or anything in terms. Okay, so now let's make it very simple, like predictive analytics. Okay, so the very first step is called data exploration, where you're exploring data, okay, to gather insights. So first you would check the count of rows, the count of columns that my data set has, or whether what kind of variables are there, or the count of columns that I have, whether what are the data types of my uh, you know typical data that my data set has. All these things could be done with uh, to explore my data. Okay, so the next comes the data cleaning methods. So now I have to study like whether my data that is there is really correct in building my a machine learning model, whether there are some features that are actually not relevant to my model, whether two or uh, two or any features that are there in it, are they hindering in building my machine learning model? Are they really good to go from the take place? Could be explored, could be found out, like how they are actually typically going through, and uh, taking place. So we can do with the use of data cleaning methods. Okay, so next come, like after my data is prepared, after I have built my features, like right now I want to transform my data, whether my data is clean. So so I need to build my features, whether my features that are there already, are they enough to build my machine learning model. So in a typical example that I gave you, like the food delivery app. So whether like for the food preparation time, whether like I have the all amount of food types, cuisine types in my model. So I need to build the types, right? If it is not there, so I may need to add some new features, add new variables, so that my model is robust. So if I am a kind of a child, if I'm a small baby, so I may need to learn so many things, right, in order to know things, my surroundings and all. So you can imagine the same with a kind of a model. You need to give it a lot of info to basically come out and make its prediction more accurate. So after doing all these things, you can actually use some of the most popular algorithms, or even you can build your own algorithms from scratch using the Python libraries, scikit-learn, and even if you are very expert, like you can use. So here we'll be typically talking about normal machine learning flow application, and then uh, after deepening researches, you can go forward and build a deep learning model. Even if you play with images, you can use computer vision. All those things could be taken place in the modeling phase. After building a model, do you think that you are very right, or can you impress your boss, or is it going right to this world, whether the model I have built? So you need to see the performance of that model, whether it's actually, you know, according to what expected is it giving the right results? So this phase is the one which is very important to judge my model, whether what performance my model is giving and all. So I can use a lot of utilities to calculate the performance of my model, which I will be seeing with a simple, application that like or a kind of machine learning model that we are going to see in the next phases. So a live demo that I will be showing you. Okay. So yeah, so this is the typical flight price prediction problem. So typically, let me talk about the problem. So let me see if anything there is on the chat or anything like that's going on. Yeah, okay, nothing. Okay, that's fine. Okay, so yeah, in a typical flight price prediction problem, so typically like if you would see like when I am booking a tickets, the flight tickets are very unpredictable, right? In every another phase, I would see so like on a day like or even in an hourly basis I would see my flight prediction price would go could go haywire, right? It could be x amount now, but it can become 2x in the next 2 hours. So how is predictable, how I can build a robust application to actually judge the prices, actually come to arrival how prices are uh, calculated or not. So it is typically very important to understand what is going behind the lines, how is the flight price being decided or not. So yeah, let's go and see a typical application in Python that I can build to predict the flight prices.